Hello, welcome. We're at chapter 3. So we're going to get started with 3.1 today. And if you can go ahead and get out your book, I wanted to just kind of go through some definitions kind of per se before I start working on problems with you. So we're going to start looking at quadratic functions, and we've looked at some in our solving and our things that we did in chapter 2, but we just didn't actually really look at their little itty bitty pieces and parts of how the symbolic equation is expressed versus how it looks on the graph. And so there's really some cool stuff going on. We did do some transformations, a little bit of transformations, but that you turned in for me in your lesson 2.3 or 2.4 homework. But this is I just think when I learned all this, it was just so cool to go, wow, I can look at this equation and literally in my mind visualize what's going on from the base equation for a base graph for quadratics. So here is the standard form of a quadratic function, ax squared plus bx plus c. So the coefficients a on a squared and the b on a on the x squared, and then b on the x, and c are all values. A cannot be 0 or else it will be a linear. And the domain for a quadratic is always the set of all real numbers. And so this graph here in the hot pink one is our base x squared graph. And then the 2, we talked about how the 2 is a stretch. It makes it get tall and skinny. And then down here on the purple one that faces down, it has a negative on the x squared, and that's a reflection. So we learned those things earlier in chapter 2. Okay, so let's go on down to the next page. Sometimes our quadratic function is written in this vertex form, and that's what's here in the second row. This is called the standard form, where you have a as your coefficient times this perfect square, x minus h plus k, and h and k are the coordinates of your vertex. And I've got this written in my paper. We're going to go over it again. And the cool thing is your vertex is either going to be your minimum point if it's a face up. And how you know it's a face up is when a is positive. So if a is greater than 0, it's a face up. You can see all that written right here. And then if a is less than 0, you automatically know it's face down, and your vertex is the maximum point. So once we find the vertex, that tells us a lot about our graph. And we're going to play around in Desmos, but you're going to learn how to read these and go, wow, I don't even need Desmos for some of this because of just things that you're going to learn about these functions. Now, there is a way to take our quadratic function and turn it into the standard form using completing the square. I'm not going to focus on that because there's other ways that we can figure out these graphing pieces without having to learn how to complete the square. Okay. There's some other transformations up there. Okay, then finding the vertex, axis of symmetry, and x-intercepts. So the vertex, if it is not in the standard form, if it's only in this ax squared plus bx plus c form right here where my mouse is, we can find the vertex by finding h. H is your x coordinate on the vertex. And if you take the opposite of b and divide it by 2a, that becomes your h. And that is now your input into your function to find out your k. Don't worry, we're going to do lots of these together. And then that h, if you let x equal h and just make a vertical line at x equals h, which is negative b over 2a, that's called your axis of symmetry. That's where if you were to draw that line, like we have right here, this dotted line, it cuts your parabola in half to where the two sides are symmetric from one another. Then we are also going to learn out how to find our zeros. So our real zeros are basically finding the x-intercepts, and your real zeros are the x value of your x-intercepts. We're going to do more about that too. And then there's a way for us to tell exactly how many x-intercepts we could have. So the discriminant is this piece right here where my mouse is. It says b squared minus 4ac. And if that evaluates to a number that is bigger than 0, then you're going to have 2 intercepts. Notice where this one on the left here, this parabola crosses the x-axis twice. If that discriminant equals 0 exactly, then you are only going to have 1 intercept. It's just going to come and touch, either come down and touch the x-axis and go up, or it's going to come from below and come up and touch the x-axis at the vertex and go down. Then there is the possibility when you find your value of your discriminant, if it's less than 0, that tells you that there are no real solutions. So notice this one here, the parabola goes up and comes down from its vertex, but never crosses the x-axis. And it could also happen up above the x-axis as well. Okay, so those are the main gist of things. I'm going to go to the first set of problems because we're going to look at some graphs, and it's easier to show you the graph of what I'm discussing. And the graphs start on the bottom of page 221 in your book. And we're going to start here. It says 13 through 20. Each of the graphs represent a quadratic function. Make the graph match the graph with its corresponding expression or description. So our choices are A, B, C, D, E, F, G, and H. And we're trying to match those. It's 13 through 20. I've assigned a few of these for your homework, so I'm going to do a few of them too. So the first one I'm going to do is look at f of x equals x plus 2, the quantity squared. Okay, so before we even start looking at the graphs, you can put this into Desmos, but I'm going to teach you how you can feel confident doing this without Desmos. So I'm going to share my paper, and because it's just fun. Okay, these are just some of my notes of what we're going to work on today. So you can see here that A is an unsaid 1 out here. And so A equals 1, and it's bigger than 0. So we know automatically it's going to be face up. Okay. And also, we can write it in the vertex format, which is x minus a -2, because it says x plus 2, but the vertex format is right here, x minus h. So we have to write it as a negative. So x minus, so h is a -2, and that's squared plus 0, right? There's nothing being added. So that means my h and k okay, sorry about that. So my h is this -2 and k is my 0. So my h and k, so my vertex is at -2 and 0. Okay, so it comes down and it stops here, and my vertex is at -2, 0. So let's go ahead and look at, I'm just going to show the book this way. It's probably easier since it's right in front of me. So we're looking for a face up where the vertex is at a -2, 0. And it looks like graph B on 221 matches that. So we've used graph B. So I'm just going to put that over here so we know we've used that one. Now, let's look at number 15. 15 says, the graph of f of x equals x squared. Okay, so our base graph shifted 1 unit to the right and reflected across the x-axis, which means it's going to be face down and shifted 1 unit to the right. So face down, so it's not G and H, it's not E. F is face down, but it's not shifted left and right, it's shifted down. And D is face down, but it's shifted 2 to the left. And it's not C because that's face up. Let's look. It looks like it's letter A. It's face down and it's shifted 1 to the right, the vertex. That 15 is A. And then let's look at 17. So I'm going to write 17 down because it's a symbolic form. So 17 says f of x plus 3 squared plus 1. So, oops. It's f of x, but that's the function, x plus 3 squared. So I'm going to write it in the standard form as x subtracting a -3 squared plus 1. So then that means my h and my k. So my vertex is a -3, 1. And I have an unsaid 1 there again. So I know that A equals 1, which is bigger than 0. So it's face up. Okay, so this is cool. We know it's face up and our vertex is at a -3, 1. So we've already done the 2 on the other page, so we can focus on our choices of C through H. So it's face up and our vertex is at 3, 1. 3, -3, 1, sorry. And it looks like E is it. It's face up and it's at -3, 1 is our vertex. So 17 is E. And then 18 has the function x minus 1 squared plus 2. So it's already in the standard form. So it looks like my h is 1 and my k is 2. So the vertex is 1, 2. And a is equal to 1 again. So it's face up. And my vertex is at 1, 2. So let's try to find that. Face up. All the ones I did were face up except for 1. Okay, so over 1 and up 2. So H is number 18. You're probably narrowing down the ones that you're going to have to be assigned to and what their letters might be. Let's look at 19. 19 says down here, the graph of the function x squared, so it's a regular parabola, reflected across the x-axis. So we're shifted down, or we're flipped over, face down, and we're shifted 3 units down. So not left or right, but just down. Okay. So, let's look at our picture choices. So we're face down, and this D is left and right shifted, and they said face down and shifted down, face down and shifted down 3. There it is, letter F. So 19 is F. Wasn't it fun? I think so. Okay. Next up, I would like to use that discriminant to tell us some things. So again, the discriminant is taking b squared minus 4ac. And if it's greater than 0, there's 2 zeros. If it's equal to 0, there's 1 0. And if it's less than 0, there are no zeros. There's imaginary zeros, but there's no real zeros. Okay. So let's look here. We have x squared minus 2x minus 1. So I'm going to off to the side write a equals 1, b equals a -2, and c equals 1. So now I have them to work with. Okay, let's look what they want us to do actually. First, I get excited. So 35 says, find the discriminant, okay, and use it to determine the number of x-intercepts of the graph. Also determine the number of real solutions to the equation. Okay, so that's all we have to do is use our discriminant here. Okay, so our discriminant is b squared minus 4ac. So b is a -2, the whole thing gets squared. minus 4 times A is 1 times C is a negative 1. So we have 4 plus 4 is 8. And the 8 doesn't tell us anything necessarily, but it does tell us, because it's positive, that we have 2 real zeros. And that means we have 2 intercepts, 2x intercepts. So 2x intercepts. Okay. Pretty exciting there. Okay. And that was number 35. Okay, let's look at 36. So 36, A is a negative 1, B is a positive 1, and C is a 3. So my discriminant, B squared minus 4AC. I write that every time just to remind myself. So B is 1 squared minus 4 times A is a negative 1 times C is a 3. So 1 plus 12 equals 13. And again, that's 0. So we have 2 real zeros. So let's do number 37 together. So 37, the function is 2x squared plus x plus 1. And A equals 2, B equals 1, and C equals 1. So my discriminant is B squared minus 4 times, oops, B squared is 1, B is 1, 4 times A, which is 2, and C, which is 1. Make sure you make that correction. B is a 1. So this is 1 minus 8, which is negative 7, and it's less than 0. So that means there are no real zeros, and there's no x-intercepts. Okay, so that means we already know, and because 2, A is 2, which is greater than 0, we know it's face up. And I haven't investigated any more than that, but I know it's face up, and it's no real zero, so it never crosses this x-axis. Okay, so it's going to come down and do something. It might be over here, it might be in here, but I know that this is about what it's going to look like. Okay, that's what it tells us. Now these two up here were, this one was a positive 1, so 35, because I know it's positive, it's face up, and I'm going to have 2 real zeros. It's going to come down and go back up somewhere, and it's going to cross twice. Okay, and then this one, number 36, is negative. A is a negative, so I know it's going to face down, and it has 2 real zeros, so it's going to go up and come down, and it's going to cross the x-axis twice as well. Okay, now it might be all over here, it might be all to the left. I'm just saying it's gonna, this is the kind of the nature. We're just getting to some of the basics right now. Okay, so let's investigate some more fun details and other ones. So 41 is the next one I would like to do, and let's read the instructions. So 41 says, find the vertex, axis of symmetry, y-intercept, and any x-intercepts of the associated parabola. Find at least 2 additional points on the parabola and sketch. Okay. Now, oops, I want to write that down. So we need the vertex. Let's just write down what we need because I get excited and I start doing things that I think are fun. But so the vertex, the axis of symmetry, the y-intercept and the x-intercepts, if there are any, and then 2 additional points. And then you want a quick sketch. Okay. So the vertex. Okay, so the vertex is because it's not in the standard form, the vertex form, we need to find the negative b over a. Let's just write this. Vertex is h and k, and h is a negative b over 2a, and then that goes into the function, and the y value comes out. So we have a equals a negative 2, b equals 4, and c equals a negative 1. Okay. Okay, that's a 1. It's got these pens. I've been wanting to use the eraser anyway because they're so fun. Okay, so a negative b is going to be a negative 4 over 2a is a negative 2. So we have a negative 4 over the negative 4, which is a positive 1. And so my vertex, I'm going to write it over here. My vertex is 1. That's my h and my vertex. And then my k is by putting 1 into my function. So if I put 1 into my function, I get a negative times 1 squared plus 4 times a 1 minus 1. So a negative 2 plus 4 minus 1 is a positive 1. So my vertex happens to be at 1, 1. So I'm going to start trying. And a is less than 2, so I know it's face down. So I'm going to go ahead and, so over 1, up 1, I'm going to say is right there. And I know it's face down, but they also want us to get our y-intercept. So our y-intercept is when x is 0, it's the y value. So we can find that. So our y-intercept. The y-intercept is cool because if it's in this form, 0, when you put it in for the y-intercept, for x, 0 makes the first term go away, and 0 also makes the second term go away. So it's always just 0 in C. So in our case, it's 0 and a negative 1. So 0 and a negative 1. So there's where we're crossing the x-axis. So I know it starts here, and it must come down something like this, and then it's going to look something like this because it's symmetric. So it kind of looks about like that. So my x-intercepts have to be on this side of the number line. So we can find our x-intercepts using the quadratic formula. So let's remind ourselves the quadratic formula. I just want to bring it up again where it is in the book. And they don't have it specifically out where I can see. Oh, they kind of do on page 214. So let me take you there. Okay, right here on the top of page 214, very small, which is odd because it's a big thing. So this x equal right here is our quadratic formula. And I'm going to write it out again on our paper. It is the x-intercept equals a negative b plus or minus, so we have to do it twice, one with a plus and one with a minus, the square root of the discriminant, basically b squared minus 4ac all over 2a. Now, students get mixed up on this because it's easy to do. And so I'm going to type it into Desmos and then save it. And I'll put the 3.1 link up into Canvas for you to kind of follow along. And you can save the quadratic formula as your own formula as well. Okay, so I'm going to write it on my paper first, and then we'll go to Desmos. So I'm going to go back and share my paper. Okay, so my quadratic formula, so my x-intercepts are going to be the opposite of b, so a negative 4, plus or minus the square root of b squared minus 4 times a is a negative 2 times c is a negative 1. All of that's underneath the square root, divided by 2 times a, which is a negative 2. And we have to do this with the plus or minus. So this would be a negative 4 plus or minus the square root of, and that's going to be 16. And we have a negative, a negative, a negative. So that become a negative 4 times 2 times 1 is 8 over a negative 4. So we're going to get the gist of it on Desmos. So let's just go there so that we can let Desmos do the rest of the work for us. Up here, I'm just going to do the quadratic formula. Okay, so number 41, let's just write here in our note that a equals a negative 2, just to remind ourselves, b equals 4, and c equals a negative 1. Okay, and so I'm going to do it once for the plus and once for the minus. So it's going to be a negative 4, and I'm going to do a division just so I've started my my fraction. So 2 times a is a negative 2, and I'm going to go back up here, and it made the negative out in front, which is fine. And so I'm going to do it first with the, oops, I'm going to go back up here and do it first with the positive. And then we have to go down to our formula, keep adding, do the square root. And then under the square root, we have 4 squared, oops. We have 4 squared. You can either do that in the keypad here, or your shift and your 6 key puts an exponent. Oops, 4 squared, and then I'm going to arrow right to make it go back down, and then minus 4 parentheses a negative 2, whoops, negative 2, and then multiplied by a negative 1. So that is the first one. It comes out to be a negative 1.07, negative 1.707. And then I'm going to hit enter. And I'm going to go up here and I'm going to copy all this and I'm going to just, oops, the whole thing, including the negative. So copy and then go down here and paste. And the only thing I'm going to change is up here, it's going to be a -4 subtracting. So that's my other x-intercept, 0.29. 0.293. And you know what? I have this other thing being graphed. I'm going to just turn that off. So I'm going to hit enter as well. I'm going to put the actual function in so you can see what these are. So I'm going to put in the function that we're doing with number 41. It says y equals. Now remember that we have a function is what they gave us, but for us to graph it, we have to do it as a y equals a -2x squared plus 4x minus 1. So we knew it was face down. And the cool thing is, look at Desmos, it already puts the dots at where we want. We already knew we wanted that x-intercept. We wanted this x-intercept. We wanted our vertex. We found that. Notice I'm hovering over those values. And we wanted our y-intercept. And that's about what we drew by hand. Isn't that so cool? So you can always find these things with Desmos to verify what you're doing is correct in your homework, but you still need to show me your work. And that's how I know that you know what you're doing. Okay, so I'm going to make sure I save this for y'all. So I didn't put that one in there. So let's do number 44. Number 44 is, I'm just going to add this as 3x squared minus 12x plus a 4. I believe, let me double check my 44 here. Yep. Okay, so I'm going to turn off my red and then I've got my blue. And why am I not seeing it? Oh, I turned it off. There it is. So we should be able to find these things, right? So when you click on the graph, then it shows the important parts. There's our y-intercept and our x-intercepts, but we're going to find those by hand in our vertex. But this is what we're going to work on next is number 44. So let's go back to my paper and just wanted to remind you of how close I was in my graph on the last one in 41. Pretty darn close. Okay, so let's just write out A equals 3, B equals a -12, and C equals 4. And because A is greater than 0, we know it's going to be face up. That's a one big hint already. And of course, we're going to try to do this all by hand before we kind of already know what it looked like because I just showed you in Desmos, but I think this is fun. So let's work on our vertex here. So our vertex is going to be a -b over 2a is what we're going to look for. So our vertex is going to be a -b, which is a negative of a -12 over 2 times a is 3. So 12 over 6 is 2. So, and then our function is going to be f of h. That's our h is 2. So my vertex, I know is at 2 and something. So f of 2 is 3 times 2 squared minus 12 times 2 plus 4. And so that becomes 3 times 4 is 12 minus 24 plus 4. So I believe in -8. Okay, -8. So my vertex is at 2 and -8. So I'm going to go over 2, and then we're going to pretend that this is -8 down here. And it's face up. So there's my vertex. Remember my y-intercept is 0 and C. So ours is 0 and 4. That gives us another point, 0 and 4 up here. And so it's going to go something like this, right? And then something like this, because they're symmetric. Oh, we didn't actually draw the axis of symmetry. The axis of symmetry, I didn't do that on the last one either. I got so excited. I knew I would do that. Axis of symmetry is an x equal, it's a line at x equal to your h from your vertex, which ours is 2. So there's our axis of symmetry. Our axis of symmetry up here was at x equal 1. Okay, so we have our vertex, our axis of symmetry, our y-intercept, and now we need our x-intercepts with the quadratic formula. So the opposite of b, which is a negative 12, so the opposite of a negative 12, plus and minus the square root of b squared, so I'm going to put that in parentheses, negative 12 squared, minus 4 times a, which is 3, times c, which is 4, all over 2a, which is 3. So we can simplify a little bit before we go to Desmos. So this will be 12 plus and minus the square root of 12 squared is 144, minus 4 times 4 is 16, times 3 is minus 48. We'll let Desmos do the work over 6. Okay. So let's go ahead to our new share here, Desmos. And I am going to, up here, I'm going to write A equals 3, B equals a negative 12, and C equals 4. Okay, and so I'm going to copy my entire quadratic formula. And I'm going to Control V. I'm going to paste it, and then I'm just going to edit mine. So mine is the opposite of a negative 12. And then I'm going to do the negative one first. So subtracting, and then inside it's parentheses, a negative 12, parentheses. Oops. Where did I just do that? Oopsie. Okay. What the heck? Okay, so negative 12 squared. And then, okay. And then minus 4, and then down here, A is 3. It might just be easier to type it over. And then C is 4. And then 2A down here. So 2 times 3. Okay. And when we click on our picture, let's see if this one over here, yep, it does match what we just came up with in our formula. So 3.633 when I hover over my dot on my graph. And now I can just copy my whole thing. Make sure you get that negative out there. Copy, Control C for copy. Come down here and Control V and paste it. And then we can just change that subtraction to an addition. And then it should give us our other 1.367. And I click on my graph and I can click on hover over that 0. And right there it is 0.367. Okay, so let's just write these down. I'm going to share my paper so that you can see them. So when you write your x-intercepts, you're writing them as 0.36. Seven, I think we said it was, comma 0. And then the other one was 3.7, I believe. 367 and 3.63. Comma 0. Those are our x-intercepts. Now our zeros are just the x value is a 0, that 0, and then this is a 0. So that is all I have there. And then you do have one problem on number 78, and I just want to go over because I'm not going to do one like this because I want you to play around with this in Desmos. So 78 says, let f of x equal x squared plus c. And this will make a slider. So it says, use a graphing utility to sketch the graph of f by choosing different values of c, some positive, negative, and 0. And then I want you to answer these questions. What can you make c? What will c be so that you have two x-intercepts? What does c have to be so that f will have two real zeros? One x-intercept or no intercepts, okay? So I'm going to show you again how you can make the slider on Desmos before we leave. Oopsie. Okay, so you can go f of x equals x and make it squared and then say plus c. And see, it says add slider c. And so when you add that, I'm going to turn off my other graph up here. So my green, this is it. So when you change c, I'm making it smaller and larger. So I want you to change that so you can answer those questions. I'm not going to save this because I want you to make your own. But I am going to put this link up so you can see what we did here in Desmos. And that's all I have for lesson 3.1. Have a great night.